What if the computer you're using right now could process information at a speed that feels almost instantaneous, 85 times faster than anything the industry has seen before? It sounds like science fiction, but Apple just pulled it off. This isn't a small, incremental upgrade. This is a seismic shift in how artificial intelligence understands the world around us. For years, AI has excelled at words. It could generate stories, essays, code, anything built from text. But ask it to interpret the real world. A photo, a diagram, a medical scan, or even a messy handwritten note. And suddenly, its brilliance seemed to crumble. That's where vision language models, VLMs, enter the picture. These systems combine text with imagery, enabling machines to not just read, but actually see and comprehend. Imagine showing an AI a chart and asking, what does this trend mean for the economy? Or handing it a blueprint and asking, is there a design flaw here? That's the promise of VLMs. But here's the paradox. The higher the resolution of the image, the more details the AI captures. Yet the more details it captures, the more overwhelmed it becomes. Every pixel adds complexity, and with complexity comes lag. The AI gets buried in its own data, choking out tokens so slowly that the user is left staring at a blank screen, waiting for anything to happen. That delay has a name, TTFT, time to first token. It's the AI equivalent of someone pausing too long before answering your question. And just like in human conversation, that silence destroys the illusion of intelligence. This is exactly the bottleneck Apple set out to break. And they didn't just nudge the line forward, they obliterated it. Apple's new model doesn't merely respond faster, it delivers the sensation of true real-time thought. No awkward pauses, no waiting, just instant comprehension. And here's the kicker, it doesn't run on some multi-million-dollar supercomputer in a lockdown lab. Apple demonstrated it working directly on consumer-grade hardware, machines everyday people already own. So how did they achieve the impossible? To answer that, we need to rewind and look at the long, messy history of vision. Language models, the clever tricks, the failed shortcuts, and the roadblocks that have kept AI from reaching this point until now. Next, we explore the flawed past approaches that Apple decided to leave behind. Section 2, the old ways, hacks, workarounds, and limitations. Before we celebrate Apple's breakthrough, it's important to understand the battlefield they just stepped onto. Vision language models aren't new. For years, researchers have been trying to teach machines to see and understand, and their strategies read like a book of clever hacks. The earliest systems, names like Frozen and Florence, relied on a method called cross-attention. Imagine trying to weave two threads together, one representing text, the other images. These models literally interlace the two inside the AI's layers, forcing them to interact at every level. It was brilliant in theory, but painfully slow in practice. Like trying to knit a sweater out of spiderwebs, it worked, but at a pace no one could tolerate. Then came the second wave, auto-regressive approaches. Models like Leva, Mini-GPT-4, and Cambrian-1 tried something different. Instead of weaving images and text together in the middle, they fed them side by side into the language model. The goal, simplicity. Let the AI juggle both streams at once. This solved some speed issues, but introduced a new monster token overload. Here's why. Most of these systems leaned on clip-style transformers, engines built to chew through images and spit out thousands of visual tokens. Tokens are like puzzle pieces the AI has to reassemble into meaning. The problem, too many puzzle pieces bogged everything down. Imagine asking someone to solve a 10-piece puzzle versus a 10,000 piece one. The second takes forever, no matter how smart you are. Researchers tried pruning tokens, chopping them down mid-process. Techniques like prime merge and matryoshka token sampling sliced away excess data to lighten the load. Others restructured the AI itself with hierarchical backbones, progressively downsampling images into denser representations. It helped, but it was like trimming branches off a tree while the roots kept growing deeper. One group even abandoned transformers altogether, experimenting with convolutional-only systems like Convolava. They were faster, sure, but sacrificed accuracy. In short, the industry was stuck playing whack-a-mole. Every fix solved one problem while creating another. Faster models lost precision. Precise models lagged unbearably. And through it all, TTFT, that dreaded silence before the first token, haunted every design. And this is where Apple's story takes a turn. Because instead of playing the same game of patches and shortcuts, they decided to rip up the rulebook and build something fundamentally different. Enter Apple's Fast VLM, a hybrid design blending the best of both worlds. Section 3, Apple's breakthrough. The hybrid engine. So, what did Apple do that nobody else dared? They built Fast VLM, powered by a vision encoder called FastViT-HD. Instead of choosing between convolutional systems, fast but shallow, and transformers, slow but deep, Apple fused them. Think of it as building a sports car with the raw torque of a muscle engine and the agility of a race-tuned suspension. Convolutions handle the quick, local details, edges, textures, tiny features. Transformers step in afterward, capturing the big-picture context, relationships, and meaning. Here's where Apple's genius shines. Typical hybrid systems stop at 4 stages of processing. Apple added a 5th stage, an extra downsampling layer that shrinks the image data even further. That one addition changes everything. Instead of the AI drowning in thousands of visual tokens, it processes far fewer, but without losing resolution. It's like condensing a 1000-page novel into a 200-page edition that still tells the whole story. The architecture is elegant. First, 3 convolutional stages strip out noise and compress details efficiently. Then, 2 transformer stages sweep across what remains, reasoning through the image globally. The result? Fewer tokens, faster response, and crucially, no sacrifice in accuracy. Numbers make the story even more dramatic. In tests, Fast VLM achieved 85 times faster TTFT compared to some leading systems, while being 3 times smaller. On benchmarks like text-based VQA, visual question answering, it actually outperformed rivals that required massively more computational effort. But speed and accuracy aren't the only wins. What makes this radical is where Apple ran it on a MacBook Pro. Not a supercomputer, not a 128 GPU cluster, a consumer device. That detail signals something big. This technology isn't theoretical, it's practical. It's designed for the machines you and I already use. By solving token overload at its root, instead of hacking at it with band-aid fixes, Apple has shifted the conversation from what's possible in labs to what's possible in living rooms. But benchmarks only tell part of the story. The real test is how this system behaves under pressure. Scaling resolution, juggling tasks, and competing head-to-head with the best AI models in the world. And in those tests, the results are jaw-dropping. Next, we dive into Apple's benchmark results, and why they should make every rival nervous. Section 4. The numbers that shocked everyone. Benchmarks in AI can sometimes feel like vanity metrics. Small percentage wins that only matter to researchers. But what Apple just pulled off, it's not incremental, it's a landslide. Take Lava 1.5, one of the industry's strongest multimodal setups. When pushed to max resolution, Apple's Fast VLM hit a 3.2x improvement in TTFT. At scale, the difference widened dramatically, up to 85 times faster response times, with a vision encoder that was 3.4 times smaller. That's not just efficiency, that's domination. On text VQA, Apple's system outperformed Conv-Next by over 8%. Across broader benchmarks like Seedbench, MMU, and MMVate, Fast VLM consistently matched or exceeded state-of-the-art models. And here's the kicker, it achieved this while generating 5 times fewer visual tokens. When stacked against Cambrian 1, another heavyweight multimodal model with multiple encoders, Apple's design was nearly 8 times faster. Training efficiency was just as striking. Using only a single node with 8 NVIDIA H100 GPUs, Apple trained the model in hours, not weeks. The multi-stage approach, resolution scaling, instruction tuning, checkpointing, made it not only fast, but modular. Researchers and developers can actually pick up the release checkpoints and test them themselves. That's an open invitation to the community. Try and break this. But maybe the most jaw-dropping detail, scaling resolution directly works better than tiling. Competing models like AnyRes or Sphinx split images into tiles and stitch them together. Apple's system, it simply digests the entire high-resolution image whole, cleaner, faster, smarter. In short, Apple didn't just win one race, they changed the rules of the game. But what does this mean for you and me, everyday users? Because benchmarks are one thing, but the real impact is how this technology transforms the devices we rely on daily. Next, how Apple's AI leap could redefine everything from laptops to iPhones, and why this future might be closer than you think. Section 5, why this changes everything. Let's step back. Why does this matter outside of labs and leaderboards? Because Apple proved something no one else dared to. Cutting-edge AI can run locally, efficiently, on consumer devices. That means your next MacBook or iPhone won't just be faster. It could become an AI assistant that truly sees the world around you. Think about it. Instead of uploading your photos to a cloud server to analyze them, your device could interpret them instantly, privately, securely, and offline. Imagine pointing your phone's camera at a form, a tax document, or even a foreign sign while traveling, and getting a perfectly accurate interpretation in real time. No lag, no internet dependency, no compromises. This shift doesn't just unlock convenience, it transforms trust. By cutting latency and keeping AI processing local, Apple sidesteps one of the biggest criticisms of modern AI: privacy trade-offs. Your data doesn't need to leave your device. And here's the more unsettling angle. For years, people assumed AI breakthroughs would always belong to big labs. Google, OpenAI, Anthropic, running giant server farms that only corporations could access. Apple just broke that illusion. They showed that world-class AI can fit on your laptop, at speeds that embarrass server-grade competitors. That raises questions and tensions. If Apple can do this, how long before local AI assistants disrupt industries built on cloud-based models? What happens to companies charging monthly fees for AI services if the same power runs offline, for free, in your pocket? There's excitement here, but also fear. Some jobs will vanish as AI becomes both faster and cheaper. Some companies will collapse. And for everyday people, the question becomes, do you adapt quickly enough to ride this wave? Or do you risk being left behind? Because this isn't just about benchmarks, it's about a future where AI is no longer a distant tool we access. It's a companion running silently and efficiently on our own devices. And that future isn't 10 years away. It may be months. In the final section, we'll confront the big question, what this leap means for the world, and for you personally. Section 6, the bigger picture and closing thoughts. So where does this leave us? On one hand, Apple's breakthrough feels exhilarating. Faster, leaner, smarter AI, running locally, privately, securely. For many, this is the dream, AI that enhances daily life without intruding. Imagine Siri evolving into a real assistant. Not the clumsy voice on your phone today, but a system that can truly see, think, and respond with depth. On the other hand, the implications are heavy. Every major leap in technology reshuffles society. Some people will seize it, adapt, and thrive. Others will be caught off guard. When personal computers arrived, some became billionaires. Others lost entire industries. The same happened with the internet. And now, AI is that next tidal wave. Apple's Fast VLM isn't just a new benchmark. It's proof that AI doesn't have to be confined to massive data centers. It can be in your backpack, on your desk, in your pocket. That democratization of power is both thrilling and terrifying. Here's the question, will you prepare for this shift, or ignore it until it's too late? Because make no mistake, this isn't a distant headline. If Apple has shown it working on consumer hardware today, competitors won't be far behind. Within a year or two, this kind of performance may become the baseline, not the breakthrough. That means the tools we use for work, creativity, education, even survival in a digital economy, are about to change fundamentally, and the divide will grow sharper between those who embrace these tools and those who resist them. Some will rise, some will stay where they are, and some, unfortunately, will fall behind. The only constant, change itself. And today, Apple reminded the world that in the age of AI, change doesn't creep, it leaps. So what side of history will you stand on when this new wave hits?